Good morning and welcome to our special yet unfortunate case on methylmercury in Ontario's provincial bird, the common loon. Inorganic mercury from the air is dissolved into water where species can change it to the highly toxic and highly bioavailable methylmercury. Methylmercury in high concentrations in our environment can be attributed to methylated mercury from industrial discharges or other anthropogenic sources. The first reports of methylmercury toxication came out in 1850s, but it wasn't until 2008 when the Mercury Export Ban Act was signed into law. Anthropogenic release of mercury is on the decline, however, levels of methylmercury in fish and birds is only rising. The common lake fish in North America have had commercially unacceptable levels of methylmercury for decades. Studies regarding methylmercury exposure to fish-eating birds have been in practice for over 30 years. The common loon is an essential bioindicator of the presence of methylmercury in North American ecosystems. Loons eat a variety of fish types, but their high dependence on piscivores such as perch leave them at risk for high levels of bioconcentration of methylmercury. As highly lipophilic and persistent toxicants such as methylmercury make their way up the Great Lakes food chain, colonial fish-eating birds bioaccumulate the compounds, and it can be fatal.
One of the major effects of methylmercury on loons is that it decreases their energy levels and productivity. This was examined in a study observing behavioral changes in loon upon administration of methylmercury in comparison to the control group. It was found that methylmercury in excessive amounts binds to proteins in muscles as it's a neutral molecule that can readily cross membranes, which causes lethargy, thus negatively impacting important operations in their day-to-day life. Another major effect is seen in their reproductivity. It was found that loons can reach reproductive impairment if their consumed prey contains high concentrations of methylmercury, which can ultimately lead to reproductive failure. For example, the odds of hatching are 86% lower for loons who ingested methylmercury versus the control group, which ultimately can impact their population numbers. Lastly, methylmercury can cause molting failure, specifically in the full remigial molts that loons experience for 2 weeks during the winter. This impairs their flying conditions as molting replaces old and/or damaged feathers. Another one of the major findings of the implication of methylmercury in loons was that it was found to cause many adverse effects. Firstly, a study found that methylmercury is immunotoxic in loons as it causes a reduction in the productivity of T cells, which is a type of blood cell that is needed for basic immune response. This was found when comparing loons who have received a dose of dietary methylmercury in comparison to the loons that did not. Moreover, a simple antigen test revealed that the loons with the dose of methylmercury failed to fight that antigen due to their lack of reactivity in their immune system. As previously mentioned, this was linked to their productivity of T cells, as their productivity was suppressed following their ingestion of methylmercury. To protect our provincial bird, we need to raise awareness and continuously support research to combat methylmercury contamination. Together, let's ensure a future where common loons thrive and our environment flourishes.
Take action today!